Okay, let me go over this week and the week after when we come back from the break. Did we all get the new updated calendar, December calendar yesterday? Okay. But we pretty much covered what we need to cover for the quiz. Our quiz is going to be Tuesday after break. So I do want to finish up a little bit with our notes because we haven't maybe just need some more practice with chain rule and implicit. But you're going to see that outside of the new derivative rules, our process will feel the same: product rule, chain rule, quotient rule, implicit, and that's what we're going to have our quiz on. So we're going to finish up notes. We're going to do our worksheet 1 quiz review. Tomorrow we'll do another quiz review in your packet. Okay, and then after and then I'm also going to be checking this homework. So this homework for tonight is from 2.3, sorry, 2.4 and 2.5. It's in your packet. It's in your it's in your the homework printout that I have for you. Okay, so after break, after break we come back Monday. We'll do another review worksheets and just going over the same things that we're going to be doing tomorrow. Your quiz will be on Tuesday, and initially we're going to have the test Thursday the 8th, but it's now going to be the Tuesday of that final week. Okay, and that gives us a little bit more time to kind of space things out a little bit. So we still need to cover curve sketching, trig related rates, and inverse trig derivatives. The 6th is a remote day, and we'll have a help session on Teams, and I'll record that as well. And then we're gonna have a bunch of days for review. Okay, so 7th can be or will be our first review day, test review day Thursday, review day Friday, review day Monday, and then test on Tuesday. Now I know that everyone kind of has different schedules towards the end of the semester, so I do want to give that flexibility for any students who want to take the test early. They can take it, just find a day find time with me either before school, lunch, or after school. If you want to take it any of the earlier days, then that kind of gives you that flexibility whether you want to take Tuesday or take it a day or 2 days before. Okay. Yeah. So there's trying to stagger the departments, not giving the tests all on the same day. There's going to be a lot of tests leading to going into that last week. So math and science is scheduled to be Tuesday. ELA is Monday, and I think other subjects is Thursday and Friday. So they're trying to space things out so students don't get stuck with 4 tests on one day. But I still want to give the flexibility for any students who want to take it earlier. Wednesday, Thursday, Friday are all going to be half days, and they'll just be recovery or makeup days. Okay. Any questions about the calendar? So if we can go to our trig unit packet. And like for us to finish page 10. So page 10 in your packet. I think we got through number 3, right? We got through example 3, which is chain rule. And we're going to see a similar process with example 4. Okay, so page 10. So whenever we see radical, we're always considering the same thing. How do we rewrite the problem? so that we can see our derivative steps a little bit more clearly. So for example 4, what do you think we can do first? Yeah, and how would you rewrite it? Good, right. Get that radical to show as a rational exponent. Sorry, I meant to say y equals. Okay, I'll put it outside a set of brackets. All right, look at how this is set up. Similar to example 3 here, we have to rely on what rule here? Chain rule, right? So chain rule, that's the big picture here, and we can look at the individual derivative rules later. Okay, so identifying the outside and inside. The outside is that bracket to the 1/3. That inside is that tangent of u, right? And that u is that whole set of parentheses. Okay, so let's go through the first part here. Outside's derivative is what? 1/3, okay? Keep the inside. Okay, raised to the. Okay, so now that we've taken care of outside's derivative, we have to worry about the inside's derivative. So as a reminder, tangent's derivative is secant squared u times u prime. So if we follow that rule here, what would you put? Secant squared, big parentheses, good. Times plus u prime. Good. The whatever's inside the parentheses, we take its derivative. So 24x cubed plus 3. Okay, everybody okay with that? The important thing is making sure that you have that bracket, because visually it's a lot easier to see what needs to happen with chain rule and the outside, and identifying the outside and inside portion if you have that bracket to the 1/3 showing. Right? So now I'm just going to try to put everything under one fraction and place everything that is going to be in the numerator together and all the denominators together. So these two are going to be in the numerator, and then the 3 and the tangent, the negative 2/3, the negative 2/3 can be brought down to the denominator. Okay. So y prime equals. Okay, not much we can do to clean up. I guess we could factor out a 3 and reduce with this 3, but that's fine. Okay, any questions with 4? Okay, number 5. We're not going to find y double prime. We're just going to find y prime. This is the type of notation that I think a lot of students struggle with, just because, just because of the notation here. But what does this notation mean? What does that mean? What does that 2 mean? Squared. Okay, what's being squared? The entire secant function. Okay. It's not a big deal. You guys probably already knew that.
but the issue is taking the time to rewrite it. If you do not rewrite it, or if you do rewrite it, it's going to be a lot more visually helpful for you to see the need for, guess what we have to do here? Chain rule, okay? And if you leave it in this form, doesn't mean that I won't take off any points if you don't rewrite it, but the tendency is the students who make mistakes with chain rule typically are the ones who don't have this rewritten, because it's harder to see that outside inside portion and the need for chain rule if you don't rewrite it. So this is a nice way of writing in terms of shorthand, which is fine, but in terms of our derivative calculus methods and steps, this is a much more beneficial format. Okay, so whenever you see that exponent in the trig function that's written in this shorthand form, take the time to rewrite it. Otherwise, you're just going to take a risk with potentially make a mistake. Okay, so we said chain rule. Okay, outside, inside. Okay, outside is, yeah, so bracket squared, right? Inside is that secant of u. Okay, the square is for the secant, the square is not for the pi and x. Okay, those will stay as just the first power. Okay, outside's derivative. Yeah, set it to bracket to the first power. Okay, we keep the inside alone. So now taking care of my outside's derivative, I'm ready for my inside's derivative. Secant's derivative is secant u tangent u times u prime. So let's just follow this derivative as we build out from what we have. So what would you say? Secant pi x becomes what? Secant pi x and pi x times. Okay, what's pi x is what's u prime? Just pi, right? If it was 3x, it would be 3. Pi x would just be pi. It's not terribly difficult, but it's a lot harder to go through this process if you just see that 2 there and you try to go down that process, right? Seeing that bracket there is really helpful, helping you identify the outside inside. Okay, so cleanup. We're just going to put the coefficients out in front, so the 2 and pi can be out in front. I can merge these secants together, and if I want to go back to that shorthand form of writing it, secant squared pi x. That's good. Now, if it was on the AP exam, and if you saw this problem on multiple choice question, this would be the way that it was written. It would write it this way. It would clean up a little bit. It would merge the secants together, and it would put it in that back to that shorthand or shorthand form. Okay, we're gonna get more practice with this, but I think this is the biggest, the most common issue that I see with trig derivatives. Just either knowing that it's chain rule, but not quite able to fill out all the parts, and rewriting it using bracket, I think is going to be a lot more useful and helpful and more familiar, right? If you see it in that form, you know what to do because you've done it so many times from previous units. All right, so let's look at example 6. Can we identify what's the big picture here? What's going to be involved with this problem? Implicit, yeah. You see y's all over the place. We're going to have to collect them. Okay. Can I do any cleanup here? Can I distribute the sign through? No. Okay, we cannot distribute sign through. That x plus y is inside the sign function. Now, if it was sine of x times x plus y, then that's fine. Okay. Then sine x is a standalone term. It can distribute through the x plus y. But the x plus y is not a standalone from sine. It's inside that sine function. So we can't distribute. Yeah. we can't see those as two separate things. So we got to jump directly into our derivative rule, right? We got to go through our sine's derivative, right? Sine u becomes cosine u times u prime. So let's step through it. Sine of x plus y becomes cosine of x plus y times the derivative of u. What's the derivative of what's inside the parentheses here? Good, 1 plus dy dx, right? X becomes 1, y goes to 1 dy dx. Okay, now this is outside the cosine function. Okay, so these are two separate things. Okay, the 1 plus dy dx is not stuck inside the cosine, it's outside of it. Okay, keep going though. We got to find the derivative of both sides of our equation. So 3x becomes, and 2y becomes, get e2 dy dx. Okay, our calculus is done. Now we're just trying to collect our dy dx terms. But you see how dy dx is stuck inside the bracket with the cosine outside of it. So this we can distribute. Okay, this we can distribute to kind of free up that dy dx. We can kind of move it around, but right now it is kind of stuck in that factor form. So let's distribute that cosine of x plus y. Now, cosine x plus y is one term. Okay, so it kind of all right, kind of goes together. Just this one big term that has to all stay together. Okay, so now that we have four separate terms, we're going to identify the terms that have dy dx in them and try to get them to be on the same side so we can factor out that dy dx, because ultimately we're just trying to get that dy dx by itself, right? So I'm going to put those two terms on the left side so that I can factor my dy dx out. Terms that do not have dy dx, I'm going to move it to the right side. I can factor and then I can solve for dy dx. So subtract over. All right, so the cosine x plus y dy dx minus 2 dy dx, I can factor out the dy dx. Divide that over, divide the bracket over. Can I reduce anything here? Can I cancel out one of the cosine x plus y's? Feels like it, but why can we not do it? Okay, it's attached to the minus sign right now. If they were standalone, if it was 3 times cosine over 2 times cosine, then yes, we can take out. But that minus, right, anything that's across addition and subtraction, it's not as clean as we would like. Okay, that has to stay in that form. Okay, any questions with example 6? Okay, let's go to page 13. And we're going to work through. We're going to try to get through 1 through 3. Okay, 1 through 3. And then whatever we don't finish, we can do that tomorrow. Okay, so look at number 1 on this is page 13. All right, what do you notice? First thing we can do is what? Yeah, put that 3 outside, right? So that's a great habit to start building, right? Anytime you see cosine in that shorthand form, rewrite it. Otherwise, it's harder to see the need for chain rule. It's harder to apply chain rule. Everything just feels less clear. Okay. Okay, hopefully we recognize the need for chain rule.
So we got that bracket cube, which is our outside. And then cosine pi x squared is our inside function.
And now we can take turns with each derivative, right? Okay, bracket cube becomes 3 brackets to the second, keep the inside intact. Times, now we're ready for cosine of pi x squared, which is what? We got to do the whole derivative, right? So cosine of u becomes negative sine of u to the pi x squared times 2 pi x, right? So make sure that you don't jump into that 2 pi x a little too soon, right? You're taking the time, negative sine of u times u prime. Remember, pi is not a variable, so there's no need for product rule inside that pi x squared. Just bring down the 2 pi x. That's good enough for our power rule. Is good enough for our derivative. As far as cleanup goes, we can put the 3, the negative, and the 2 pi x in front, and then everything else after. So 3 times -1 times 2 times pi times x.
Why is it -6? Why is it -6?
Because I put the negative, I pulled the -1 out in front as well. So 3 times -1 times 2 times pi times x.
Would it matter if you left the negative with the sign?
It wouldn't matter, but you have to make sure that you put a times negative. It feels a little cleaner in terms of this presentation. And I want us to, if you put a negative in here and you're clear that it wasn't a minus as times, I wouldn't take any points off. But I do want us to practice this form because if it was on AP exam, this is the way that they would write. They would put all the coefficients out in front. They would, any trig that is raised to a power, they'll put it in the, without the brackets and put it in between. I want us just to.
Is it okay if we leave the brackets?
That's fine, yeah. If you leave with the brackets squared, that's fine as well. I do want us to practice interchanging between these two, right? This is a great form for our derivative process, but this is the form that they're going to show at the end of the problem on the exam if they're looking at multiple choice.
Okay, good. Take a look at number 2.
Okay, what's needed here? Quotient, okay, quotient rule, right? Quotient rule. What is that y prime of 0? What's our end goal there? Slope, right? So this means that after we find the derivative, we can do what?
So that's
30
equal to 0.
Yeah, 0 for x, right? We don't want to set slope equals 0. We want to figure out what is the slope at 0. Good, okay. So the nice thing is when you go through and you find your derivative going through quotient rule, it's going to be really messy. But you don't have to spend the time to clean it up because as soon as you insert 0 into your messy derivative, things will collapse and reduce a lot faster. Okay, so in problems that's only asking you for slope, we can speed up the process by not having to clean up our derivative. We can just insert our value and just try to get it down to a numeric value.
Okay, so let's set up quotient rule here. F prime g minus f g prime all over g squared. A reminder of your derivative rules. Sine's derivative is cosine of u times u prime.
And cosine's derivative is negative sine of u times u prime.
Okay, so f prime, what's f prime going to be? Yeah, cosine pi x times pi, right? Cosine of u times u prime. Okay, so here's my f prime. My g is going to stay the same. My f is going to stay the same. of my g prime, what's g prime gonna be? Cosine of two pi x becomes negative sine two pi x times two pi. All over 2 pi x squared. Now, where do we put the squared though? Yeah, so either you put it in between, outside a set of brackets, but you don't want to put it as cosine 2 pi x squared. What's wrong with that?
You're only squaring the principal.
Yeah, then you're only squaring what's inside cosine, not the entire thing. So it doesn't seem like a big deal, but it's, you know, that very subtle change in location of that exponent is making things different. Okay. So we want to make sure that it's the cosine that gets squared. It's not the parentheses that's getting squared. Okay. Looks like a mess, but once you insert 0 for all the x's, a lot of things will clean up the next issue. So I'm not going to spend the time to clean up. I'm just going to insert 0 in for all the x's. So cosine of pi x, pi times 0, which is 0. Cosine of 0 is what? 1. Okay. And then the 0 gets plugged in for all the x's for sine. Pi times 0 is 0. Sine of 0 is what? 0. So that's nice, right? Everything after this minus sign, they're all connected by multiplication. As soon as 0 shows up, it's going to wipe everything out to be 0. So this whole thing just goes away. And then bottom here, cosine of 0 squared is just what? 1. So that is just 1. So a lot of things just cleans up, goes away. Cosine of 0 is 1. Cosine of 0 is 1. 1 times pi is pi. Anytime a 0 shows up with multiplication, it's going to just take everything out. And then divided by 1 squared, pi minus 0 over 1 is just pi. So the slope of this original graph at 0 is a slope of pi. Slope of around 3. Okay, let's try number 3. Hey, take a look at how number 3 is set up. What things come to mind as you think about what we need to apply? Quotient rule. What else? Implicit, right? I got that y inside my equation here. I've got to collect my dy dx. Okay, so let's set up f prime g minus f g prime all over g squared. Okay, f prime cosine of x becomes, sorry, sine x becomes cosine x.
I'm sure.
Right. G function, we keep the same, minus f function, we keep the same. G prime, let's about G prime here. What does 3 cosine of y become?
Negative 3 sine.
And you go, negative x. Negative 3 sine of y of dy dx. Okay, so we gotta make sure we have that y there. We don't want to just lose that y. Right, it's negative sine of u times u prime. So we got to keep that y and then dy dx shows up. Right, all over denominator squared. Don't forget the right side equals 2x, but 2x becomes 2. Any questions? This is the only calculus step. Everything after this is just moving things around, trying to solve for dy dx. Everybody okay here? All right, I'm going to try to do this a little bit of cleanup here. I'm just going to put these together, put those together, combine the negative together, and I'm going to cross multiply. That's a quick way for me to get the denominators to change locations or to be rid of them. So 3 cosine x cosine y
I made -1 times -3 a +3, 3 sine x sine y dy dx. There's only one dy dx term, so that makes it easy. Once I cross multiply, I can just get that 3 sine x sine y dy dx by itself and just divide that over to the right side. Once I cross multiply, subtract the 3 cosine x cosine y to the right side. Then that 3 sine x sine y is by itself, divide that over. And we can go one step further, because both the numerator and denominator, they both, well, numerator has a 3 that I can factor out, and that 3 can match with that 3 below. So any GCF that I can take out, if there's only one term below, that means it's fair game. I can just match and cancel out with this.
Oh, wait,
Yeah, there we go. Yeah. So yeah, good point here. I want to make sure that we understand that that square is affecting both the 3 and the cosine. So that 3 squared becomes 9, 9 cosine squared y, and that cross multiplied. Okay, 4 is a little messy. We can come back to it, but there's one last thing that I want us to do. And I want us to practice writing out our 6 derivative rules. Okay, so let me go through these again, kind of talk about the patterns, and then I'm gonna have you guys practice, see if you can recall these from memory. But I wanted to draw as many connections as possible so that it feels like you're just looking at the trig functions to create your derivative rules rather than memorizing them all from scratch. So let me go through the process here. I think this is a great thing to be able to have at the top of your quiz when you write, and also this is great to also have on the AP exam. On the AP exam, these only look like 6 rules to you, but it's actually 12 rules, because when you talk about antiderivative rules next semester, we're just working backwards. And just by having written 6 rules down, you really have 12 rules in front of you, and that's going to be really useful. So it's going to serve a purpose for us next semester as well. Okay, so first column, sine, tangent, secant. Second column, you're going to write all your C functions, trig functions in alphabetical order. So COS, COT, CSC. Okay. Whatever are across from each other are all going to share a very similar format, right? Sine's derivative is cosine, cosine's derivative is sine with a negative in front. So these are easy. You should remember that all your C functions produce a negative derivative. So really, you're just looking around to gather your derivative rules. You're not really creating anything from scratch. Tangent's derivative is just looking below, right? So tangent is just going to rely on secant. It's just going to be secant squared u times u prime. And then cotangent will be a copycat. It'll just look at what tangent's doing and it's going to look below and do the same thing, but with a negative in front. And secant's derivative is just involving itself and the one above it. So secant u tangent u times u prime. And then cosecant's copycat. It's going to just do what it sees above. Negative cosecant u cotangent u times u prime.
So spend a minute, look at that. And I want you guys to find any blank sheet where you can try from scratch, right? If you mess up, it's okay, because we're just going to practice each day. Okay, you guys ready to try it? Give you guys another minute. Okay, let's see how we did. Did we remember to include the negatives for all the second column ones? A great way to double check is look across, right? It should look similar in terms of their format, similar in terms of the formats. We'll practice again with this tomorrow. You guys have homework tonight from 2.4 and 2.5. I'll remind you this afternoon.
You already raised it, I don't get it.
I know, we stared.
Start now.
I mean, if you want to come back next thing.
That was that serious, didn't it? Now I gotta go. So, don't worry, I'm not going to do that. Before the game is crazy.
Well, no, it's not even that, like, I know we just like, wouldn't play, like, ball with them. Like, I got like stuff up there.
Yeah. Are you gonna, I mean, like,
He always texts me, "Can we do that?"
I was just fairly make it. I'll like about it. I feel like I'll walk, and I walk through the main doors. I walk through the main doors. I keep the pop. Not what you.
First, Bucketeers practice midnight. Hold up. That's that, I'm not gonna do that. I got, so.
We ain't even dedicated, bro.
Damn, where am I going?
You ain't even dedicated.